So in this problem, we are asked to evaluate the integral -5 to 1 of 1 over 10 plus 2x dx. How exactly do we go about this? Well, there's something you need to know. This is a simple u sub problem. You'd get ln of something, right? Because it's 1 over a function of x, a linear function, linear factor. But there's a problem. Notice the denominator, 10. If we were to evaluate, because it would be ln of something, blah, 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 over here, 10 plus 2 to the -5. Okay, so ln of 10 minus 10 is the natural log of 0. Now, type in the natural log of 0 in your calculator, you're going to see that you get an undefined answer. You can't take the natural log of 0, unfortunately. It's undefined. So, and there's a reason for that. Because, and you're going to see that this is an interesting thing here. Our graph, when we graph the function, we're going to notice at -5, our function is just going to skyrocket to infinity. It will never cross. It's a vertical asymptote. Remember, when you were probably in pre-calculus or algebra 2 to find a vertical asymptote, you set your denominator equal to 0, your factors of your denominator equal to 0, you solve for them. -5 is here because I'll just go through it quick. Plus 10 equals 0, subtract it over, x is equal to -5, right? So there's a vertical asymptote there. That means that the area in this section is going to be infinite. Okay, so we need to redefine, to evaluate our integral, we need to redefine this lower bound here. So we're going to say the integral and the limit as, we'll call the lower bound c approaches -5 for the integral from c to 1 of 1 over 10 plus 2x dx. So now we simplified it here. We'll take the integral, we'll evaluate it. We're going to see that, and we'll just do u sub, u equals 2x plus 10, where du is equal to 2. And our numerator, we know that this is 1 over a linear factor. That's going to be a natural log. And so we need to get 1 up here. So how do we do that with du? Well, we need to divide. So 1 equals du over 2. Hopefully that makes sense. So what this simplifies to is the natural log of the absolute value of 10 plus 2x. And then we need to bring out a 1/2 here, right? Because when we take the derivative of this, we'll see that we get exactly this. Alrighty, so we're evaluating this from c to 1, and we have a function of a limit as c approaches -5. Hopefully that makes sense to you there. Now we need to just evaluate this limit. So let's go ahead and evaluate this bound. This is going to be 1/2 ln of 10 plus 2, which is just 1/2 ln of 12. Okay, and we're going to subtract that by 1/2 ln of 10 plus 2c. Right, and we have that limit as it approaches -5. Well, what happens as we approach -5 on that graph that we saw? We go to infinity, so we need to plug in infinity here. So we plug in infinity. So 10 plus 2 to the infinity is the natural log of infinity. Okay, so this is 1/2 natural log of 12 minus 1/2 natural log of infinity. This is 1 over 2 natural log infinity. Well, that will just simplify to infinity. And then this here, it's just infinity, guys. So if it simplifies to infinity, what does that tell you about this integral of 1 to 5, 1 over 10 plus 2x? Well, it tells you that there is no area that we can approximate and that this integral is divergent. Whenever we have a function that we can't find the area of, we just have to say it's divergent and move on. You can't find the area of that, right? Because if I go to negative 4.9999999, well, I'm excluding the area that would be included with negative 4.999999999. Okay, so it's just like you're excluding values that are extremely great in value, so you greatly underestimate the area, and you can't estimate the area of infinity. It's divergent. So that's the solution here, guys. I hope you guys enjoyed. If you did, please drop a like, subscribe, and comment if you have any questions. I would love to answer your questions. Have a wonderful day.